Hello, people. I'm continuing with my little frog adventure, and I thought I'll try and take you along. I'm up to a point. Where's the little? Oh, I have it selected probably. There we go. I'm up to a point now where it becomes necessary to proceduralize the jumping animation. Um, I want to add soon, but not in this session, I guess, the ability for the frog to jump anywhere in a certain area. But for that to work, I need to stop relying on an pre-recorded keyframe animation, because the length of the arc will be different for, you know, some jumps. Also, I want to be able to put the frog like over here and have it still jump into the water correctly, and maybe jump over, over there or whatever. So I will have to figure out how to kind of fake a ballistic trajectory for the little thing. I'm gonna lay down the basics first. Not sure if I should really do the mathematical bits on camera, but let's get down the basics down first. So for this to work, the one obvious thing I need is for the frog to have a jump target. And I want to use like a transform for that first. Maybe we will remove it later when it gets in the way, because every transform in Unity obviously eats resources, and all we have to know really is a world position to jump to. So that's just a parameter in the script at a certain point. But for now, I thought it might be smart to get at least set up like this with a transform. So let's see, what a surface is there. Let's build here a public transform jump target. And for now, I was thinking to make the necessary functions and stuff just by abusing the gizmos in Unity. I'm gonna add a void on draw gizmos selected. This runs in the editor if we're running or not. On draw gizmos selected. I hope the text is, the largeness of the text is now up to scrap for YouTube. I'll be abusing the on draw gizmos selected bit. Let me think. I thought of something else. To just in the editor draw like a line from from the jumping off points to the targets to how do you say, to visualize what we're doing before we are actually applying it to the frog in motion. Oh, we're compiling. It takes a while. We've just started up the system, so there will be a few pauses here and there when Unity comes up to speed with things. Let's see, just checking my volume should be good. So this frog now has a jump target, which I'll just give this here. And I'm thinking that, imagining just how do you explain? At a certain moment, I'll probably want to spawn the frogs by script as well, so I can fill up the pond with different frogs, maybe different colors even. And the locations will just be the starting points, and they will get set with a manager script which sets the jump target for every individual frog. but the point where they will start jumping is obviously just the transform of the frog itself, and everything will move inside that. So with that in mind, I think we can start. Let me have a little think. I think we will draw this in world space so that when we get to speed calculations, the numbers add up to something logical. Okay, let's first gizmos.color is color.cyan. Oh, all those errors. Color. The errors are larger now as well. So, and I'll be a bit distracted by that. And the simplest thing we can do right now is gizmos.draw line from transform.position to something with targets, probably a jump target. Yes, dot position. That should already work. There we go. So this is the path, just a linear path from source to target. I can displace the targets and have that line update. For now, I will remove the selected part here, so I will always see my my helper line, even if I select the jump target here. Thank you. So there's the basics. Now I'm gonna go into the nitty-gritty of it. I may want to skip this in the video because the chance is reasonably large that I screw up and have to redo stuff, and I don't want to bore you with me puzzling out the mathematics of this. But I'll keep talking. Maybe this is a cutoff point. If I decide to not show it, I'll see you in a bit. I left you, I think, with just the draw gizmos bit, and I've started filling out the formula that will calculate the trajectory. That will be this part here. Oh, sorry, I can't use my tablet here. This part here. Just the basics for now, just getting stuff in place. All that happens here is this one draws the magenta line that we already saw. This bit draws this line here. This will, at a certain point, visualize the this function, so to say. So I'm just picking up a time and a time step, setting the color. Let me organize this a bit. And then just walk through a set of points. From pos will start at 0, to pos will be the first step along the curve, and this I need to define when I will stop drawing the curve, because else the while function will just keep drawing the curve and lock up unity. So I just decided to go with the wrong calculation here and add an offset. This is just a visualization, so it's not important that it's entirely accurate, and really doesn't really need to end on the exact point here. So this calculation was wrong, so I just added an offset so it would draw 20 centimeters extra. And this is, in fact, just the horizontal part of the formula, so I got that working, and I think that's a good first step to sign off on, so to say. Now I'm suddenly a bit worried that I made an error. Let me check. And this is a bit hard to check, but why does it look like the... Okay. For a moment it looked like the cyan curve here, it wasn't exactly beneath the frog, but that was just perspective, playing with my mind. Should be good. So, horizontal part down. I'll start on doing the vertical part of the jump, which is just the Y component making like this motion. And I'm probably just gonna do that. Well, I'm not sure how I'm gonna do that. I want to make absolutely sure, I think, that the frog does end up. Let me use this frog here, end up exactly at the point of entry that we gave the target. So I should do some good calculations on that Y velocity. I can't just add to it and then, or give it a starting value and then remove the gravity components from it, which would be the easiest way to do it, but I have to find a better way to do that. So I had a sudden thought, a slight sudden thought. Maybe we can simply fake the actual, what's it called, ballistic curve by doing the following. Let's use a public animation curve for vertical motion. Okay. Let me try and explain what I mean once I have added this. We could, if it's once it compiles, yes, come on, thank you. We could, at a certain point, simply define this curve in the script itself, but for now, what we could do is have like, oh, can I mirror this? I can't mirror this, okay. Define a curve from 1 to 0, from 0 to 1 in time, from 1 to 0 in space, so to say. We'll treat this as the height of the starting point, this as the height of the jump targets, and then we just simply create a curve that looks nice. So I did this before in animation terms. I kinda know where to go with this. I think something like this should be good, and then we simply sample this curve to get the vertical the vertical component of where the frog is. So let's try that first. Feels a bit hacky, but should work fine actually. Should look good. Let's say it should look good, because that's all we care about here. It should look and feel good enough for what we're doing. So we have a vertical motion key here now. I'm still trying to use my tablets in the code editor, which doesn't work. And we can, let me get this in place here. We can do this here, because we will need to know where in the animation we are, because we're treating like this as the beginning of the animation and this is the end of the animation where we hit the targets. We will need to know how long the animation will take, and I was already starting to do something here that I commented out when I started thinking about the curve approach. So we will need to measure the duration, and that's simple, just, you know, take the horizontal distance to travel and divide it with the horizontal speed. I'm doing that by just making the full vector and then scaling it down so that the y-axis is 0, and that's distance horizontally, taking the magnitude, dividing by horizontal speed. Now, because we don't really want to update this every frame, I was starting to add in a little lock on the draw gizmos thing, that we only measure the duration every time that the jump target position has changed. So I will want to float duration. I want to remember that. Let's fill in some obvious value at first so my functions don't break by dividing by 0. So if this is the case, then we're gonna calculate the duration. So duration equals measure duration to, my goodness, my typing is excellent today. And then let's set last drawn target pos to jump target dot position, and hope that that doesn't screw things up too much. Let me clean up this code a little, like so. So this just locks the measured duration for any time that the target changes. Now we can work this into here, because we know which time step we are, we know the duration, so we can say that the I'm gonna do it in the wide first, so to say. So I'll just write out all my parameters and then compress the code later. So vertical phase, I'll call it, equals yes, shall we just fill in the animation cursor? Yeah, vertical motion dot evaluate for time step divided by duration. That's the vertical phase. Now we will want to multiply this with the difference. So float vertical pos is like, this is the floor or the jump target height, target dot y plus the no, this should be somewhat more elegant way of doing this. I think we can just do a lerp. Is there an unclamped? Yes, an unclamped lerp. Very nice. That's what we use that phase for. That goes beyond 1. So because 1 is the starting point, and sorry, 1? Yes, a height of 1 is actually the starting point. So we want to work backwards here. We want to have the jump target dot y here and transform dot position dot y. Sorry, I need obviously to have position here, and then use that vertical posi. That should be my vertical phase. And then we can move this over here. And okay, let me think. I think this should actually be enough for a nice curve. So I'm glad I thought of that. If it works, if it works, if it works. I'm glad I thought of that to add to the video, because then I won't leave you with two silly straight redraw lines. Something odd. But we're getting somewhere. Let's see what happens. Why? Is this because it clamps? No, I think it just draws it a little bit too low. Jump target. Why is it drawing it too low? The end as well. It did that before as well. Why is it doing this too low? That should all happen and go wrong in this here. Let me reread the bits. This is the difference between the floor position. It's the horizontal. Ah, okay, yes, yes. I'm adding the jump target position here, so we're not talking about a horizontal difference anymore. Let's do it like, wait a moment, I'm getting a bit confused. See, I'm adding the position here, whereas I'm already using the Y component of that position over here. So this is not so much of a difference if I use the absolute coordinates here. But I only use the RE difference here. Let's rename this into just results, and then turn that into something absolute here by simply adding the results. The transform.position here instead of at the end. My typing really suffers today. I'm really sorry, but this should work. Yes. 3, 2, 1. Nope. Pyoop. Can I have a poop? Yes. Okay. It's just funny that it ends up over there, but let me quickly test how it behaves. It seems to behave okay. It actually seems to not reach the target, so I think there's something wrong with my duration calculation. Also, let me inspect the lines here. No, I thought they might begin at a different time. But as you can see, this should actually work for a jumping frog. If it's a shallow jump, then it just goes in straight. I don't know if that will work every time. Maybe it is nice to really exaggerate that curve a little. So a bit like this, and more like this. So it's kind of flies half as high as that is as that it lands. So what happens if we really bring this down and the curve just gets larger? Okay, that duration, it seems correct. The curve ends correctly if it's almost flat, and there's a discrepancy if it's like getting higher and lower. So I'm thinking my duration is not, duration calculation is not correct. or that I don't use it correctly. Measure duration. Get stored in duration. Let me check. Is it actually... Yeah, it's actually calculating something. So if I here, it's here, over here. So if I move my jump target around, the duration changes, which is a good thing. But it seems that... It doesn't... update if I move it in Y, but that's okay because we're only measuring the horizontal duration. Okay, let me figure out this bug off camera. I'll come back to you when I find the solution. Yes, that's the fix. There we go. So found it. The actual culprit was this here. This was doing something weird. I'm not sure what actually, but let's just forget about it forever. This I fixed it by doing this, but I can simplify it even more because now that I know the duration, I thought I only measured the duration for the vertical components, but since we are measuring the length of the vector here and the speed, we know the exact duration, and there's a much simpler calculation we can do by just calling this the phase and calculating that there. And then we can actually do it like this. Vector 3 hori plus, hori plus. Actually, I'm gonna do it with a result vector already. Is a vector 3.lerp. Is there a lerp unclaimed? Yes, there's a lerp unclaimed. From transform.position to target, jump targets.position, and we fill in the phase there, because that's the phase is obviously 0 at start and 1 at the exact moment that it hits the target. Then we will remove the Y component. We will put that at jump target dot Y. Actually, we don't even need to do that. We can remove this whole thing. There we go. And we can make it even shorter by simply filling this in here and not caring about an extra bit. So let's see if this works. Should work. And kill me now. Obviously that doesn't work. And obviously I've now screwed up Unity completely with my code. Cool. Okay, let's see. Result.y. Okay, well, I am glad you got to enjoy that bit of nastiness. I will fix this up and see you in a bit. Okay, just discovered my mistake here, so I thought I'd explain that while I boot Unity again. I renamed this to the actual phase. This is obviously not the actual phase. This is the vertical position phase. So this one is I will rename it to vertipazi, and I'll add an actual phase. Float phase equals time divided by duration, and this we do times the phase, and this we do with the 30 phase. That should work. And to actually make it even cuter, I will fill this in here and reformat my code so I can actually read it. There we go. And I remove this. I'm fairly confident that was my my error. So one moment, I'll boot up Unity, which will take a while. Well, that was kind of an unexpected disaster. I had to kill all my assemblies because I was working in OnDraw gizmos, with which actually runs every frame in the Unity editor, and not only during play mode. Unity refused to start up, and because it seems that Unity doesn't recompile your scripts even if you fix your mistakes during startup, I had to force it to recompile the whole project by deleting stuff in the library folders, and it took a while. But I think we fixed it all. So I changed the phase over here, I think, in relation to the last bit of video that I forgot what I talked about now, because it's been a good half an hour ago. I'm evaluating the phase here, and this is now the phase of the vertical component, which is an evaluation of the vertical motion here, and now it all works. There's a slight discrepancy here at the very end. I'm not sure what happens there. That might just be... well, it's not important. I imagine that when I make this all work, the jump target will be the actual point where the frog disappears. So if the target is here, we will register that it crosses the surface with the function we implemented a few days ago, the water level reference. And once it's here, the frog will be largely invisible, so the bit of motion here at the end is not really that interesting. So there we go. My ballistics curve, well, my fake ballistics curve, because it's, you know, it's hand animatable now. This would be nice for another different creature, maybe. But my calculations are now correct, so I can move on to putting this in motion, but I will keep that for a next video. So for now, I hope you enjoyed this little scripting roller coaster, and I will see you in the next one.